Indefinite integrals. So you need your calculator out for this particular lesson because we'll be using the calculator a lot and teaching you a new trick using the math buttons that you haven't learned before. L3, area and definite integrals. So beforehand, what kind of integrals were we learning about? Indefinite integrals, yeah. Indefinite integrals where you've got a plus c at the end and that kind of thing. So we're going to be dealing, previously we were looking at indefinite integrals which have a plus c, yeah, we could say c or plus c. Oops, I did lowercase c. Uppercase c. There you go. I'm going to just make it really obvious. I don't think it matters to me. Previously, we're calculating indefinite integrals which have a plus c at the end. This plus c represents an unknown constant value. An unknown constant value. To understand what a definite integral is, we will carry out the following little quick investigation. So it's very fast, but it kind of just gives you an idea of what is the indefinite integral, and we're trying to prove what it is as well. So consider the area bounded by the function x squared plus 1. What kind of function is x squared plus 1?
Quadratic.
Quadratic, yep. What would be its y-intercept? 1. Good, yep, so it's plus 1. And there it is. Is it smiling or frowning?
Smiling.
Smiling, yep. So it's concave up, isn't it? Yep, that's another mathy way of saying it. It's concave up, and frowning is concave down. So consider the area bounded by the function x squared plus 1. Between x is 0, notice it's the area from x is 0 to x is 2. So that's what they're writing here, x equals 0, x equals 2. So considering this whole green area here, which is shaded in green. Okay, A1. Write down the width of each of the 4 rectangles shown on the graph. This is not meant to be a hard question. So if you think it's too easy, you're right. Yeah. Yeah, how did you get 0.5? Because it just is.
Between 0 and 0.5.
Yeah. Yep, exactly. It just is. Yep, so by each rectangle, yeah, they didn't mean the whole area, they meant just each little rectangle. So the width of each little rectangle is 0.5. If there were any units, what would they be? Both? Just B starts with U.
Unit.
Yeah. So you don't feel like you need to write it at all. But if you were feeling lost without writing units, you can write units. What unit? What are the units called? They're units. Calculate the height of each of the 4 rectangles. So this little one here, yeah, it's 1. Yep, that'll do. 1 for the next one. Yeah, you could look at the graph, or to be even more, you could look at the graph, but also notice it corresponds with, what x value does it correspond with? Yeah. Yeah, that's it. Yeah, so you could be even more accurate. This is another reason why you might need your calculators. So I might do the working out, put that over here somewhere. 0.5 squared plus 1. What is it again? Because my notes are on the other side of the screen.
I said 0.2.
0. Was it?
0.25.
So when you don't take this, but
Yeah,
actually,
I know, but like I'm that.
1.25. Yeah, okay, yeah, that makes sense. But then that's at 1.25. Same thing with the next rectangle. The next rectangle, rectangle 3. What x value does it kind of correspond with? 1. That's a nice one to sub in. 1 squared plus 1, yeah, equals 2. And it does make sense. It roughly matches up with 2. And the 4th rectangle, what x value does it correspond with? Yeah, 1.5. Yep, so 1.5 squared plus 1 equals... Oh, it's like 2. Oh, yeah, that makes sense. Yeah, 3.25. Let me plug it in. So 3.25. And then what it's asking us to do is find the sum. So I'll let you write that down first, sorry. And then find the sum of the areas of each of these 4 rectangles. to find the lower bound for the area of the shaded region. So basically, they want you to find the areas of each of these rectangles and add it together. So how would you find the area of rectangle 1? Yeah, base times height. And what is the base again for each one? 0.5, yeah. So whichever way you want to show working out is fine. You could go 0.5 times 1 plus 0.5 times 1.5. So you could do it that way, or you can work them all out separately and then add them together, whichever way works for you. Then let me know what you get as an answer, because as I said, my answers are on the other side of the school. 3.75, anyone else? Get 3.75 for confirmation. I remembered it was a decimal thing. If you happen to want, you don't need to write any units for these ones, but if you were lost without writing units, yeah, unit squared or squared units, yeah. Squared, if you want it. So what they found, they asked us to find, so we found the sum of all these rectangles, and the purpose of doing that was it gives us what they call the lower bound of the area of the shaded region. Would you expect that the real shaded area, the whole green area, would it be a bigger area or a smaller area than the one we just found? Yeah, why bigger? Yeah, missing these little bits that are up closer to the curve. Yep, so that's what they call the lower bound. Now we're going to use another graph for the same function. Well, it's the same graph, but see, we're using the upper bound. So beforehand we were using the lower bound. By the lower bound we mean the lower value for the rectangle as being its x, and now we're going to use the upper value as being the x. So if instead you drew it from here, this would help us to get the upper bound. Okay, so write down the width of the 4 rectangles in each of these graphs. What would be the width of each of those? Yeah, again. So calculate the height of each of the 4 rectangles. Unfortunately, a lot of them might be similar to the ones before. So what x value do you sub in for rectangle 1 this time? 0.5, yeah. So 0.5 squared plus 1. And we already know the answer. That's something you found before. Yeah, 1.25. So you might find it's some similar numbers to before. 2.5. So you could probably quickly see that the next one is 1. So 1 squared plus 1. 2. The next one was 1.5. Yeah, so the same one as before, 3.25. So just one new one to calculate, which is when you sub in 2. 5, yeah. 2 squared plus 1 is 5. So you've got all of those now. And you can probably predict that they're going to ask us again to find the sum of the areas of the 4 rectangles, and this will give us the upper bound of the area for the region, which, as you've probably guessed, is more because of these extra bits than the green area. So we do the same thing. 0, 5, 1. 5.75 could be, definitely it. We shall await another confirmation. 5.75. So, out of interest, the actual area, the green area here, what do you think the relationship would be between your answer here, 5.75, and the lower bound, 3.75? What do you think the relationship might be?
Is that your uncertainty?
Hmm?
Like your uncertainty?
Could be, yeah, yeah. And so, like, basically, what I'm asking is probably like almost too obvious.
Is that the answer?
Nah, but it's an approximation. And probably what I'm asking is just so obvious, as in, like, you think you know, you can't just be asking that.
Subtract them so you have the actual.
Good guess. It's really all it's just that the real answer would be somewhere in between the two. That's all, which almost sounds too obvious.
So you don't subtract them to find the actual answer?
No,
It's
no.
just 2 though.
Wait, but how come when we did this one,
Oh, hang on.
What's what I was saying, but she said no.
No, you don't subtract them.
this one, how come we got 1? Shouldn't we have done 0.5? Sorry.
Did we do a boo-boo back here?
Yeah, where'd you get 1?
This one? Oh, because the lower for these ones we use the lower bound, because this was for the lower. So the lower bound was 0, and when you sub 0 into
So how come we didn't sub 0 to the first one?
yeah, we could have, but 0 squared plus 1 is just 1. And you also, as you pointed out, the y-intercept was 1 already.
Yeah, but I'm saying how come we, when it says calculate express 4, how come we calculated it, how come we included 1 of this one but not 1 of this one?
Because this one asked us to use the lower bound to sub in. So for each rectangle, you use the lower bounds.
Oh!
And the next one,
This one to the left?
yeah, and then the questions at the bottom wanted the upper bound.
So to the right.
Yeah, so that's why 0 didn't get used that time. Instead, on the other one, we used 0.5, 1, 1.52. Okay, yeah. So all I was asking before, all I was trying to point out before was just the fact that the real answer to the area under the curve would be just somewhere in between those two. That's all it was. Yeah. Yeah. It was just probably the way I phrased it wasn't clear. Okay, so now we're going to use this on the next page. Now you're going to learn this fancy pants thing on your graphing calculator.
Oh, this is what Fire Level was doing.
Are they nice? So use.
We were just celebrating that we didn't have to do that. I know. I was like, where do you guys get these numbers from? They're like, oh.
That's cool. Yeah, that's good stuff. So now use your graphing calculator to find the definite integral. But notice what two x values have they got here? You might not have seen them here.
But those are X values. 0 and 2.
0 and 2, which happens to be the same as the graph. Because notice that they wanted it between 0 and 2, the area. So this is important. It's important. So notice on the integral thing they said between 0 and 2. That's because we want to find the area under the curve between 0 and 2. And then we plug in the function and then dx. To do this on your graph, on your graphing calculator, press math. Where's my calculator gone? So press the math button. Can you see on there somewhere number 9? Do you have number 9 as your function integrate?
Mm-hmm.
Yeah. So function integrate generates this funny symbol. So press number 9. You can scroll down or just press 9. And then so you can fill in the missing bitsies. Isn't this cool? And it always starts with the bottom.
Does it matter where you put the 2 or the 0?
Yeah, it does, yeah. So make sure you put the 0 here. This one has to be the one to the right. The top one has to be to the right, and the bottom has to be the one to the left, yeah. Yeah. That rings a bell. And then we put in our function, we just use the X button here to do that. Oh, and where's your calculator? Oh no. How could you? I don't even have a spare one, unfortunately. Okay, dx, or do I? Did you guys get that answer? Do I have a calculator? I do. Yeah, I have. You got that? Mm-hmm. Ooh, I need to take this thing out too. Alright, so when we did that, we got 4.6666, which actually means, like, it's meant to be 4.6 recurring, or 4 and 2/3. So it's meant to be kind of 4.6 recurring. It just rounds the last bit for you for some reason. There you go. So this number compared with 3.75 and 4.7. They're trying to give you a clue. When you calculated this, what do you think it calculated? The area under the curve between 0 and 2. Yep. So basically, that's what the integral is. This is just trying to point out that the integral, when you sub in the x values, when you sub those numbers in, you're finding the area under the curve, like up to the x-axis. So the area between the curve and the x-axis, between those two values of x. So write that in whichever words you want to do. So it is the area. Under the curve. Yeah, you write it in whichever words make sense to you. This is just something to refer to. You're going to find a lot of areas under curves. So the definite integral represents the area under the curve between x is 0 and x equals 2. If it helps in your memories to look back on, like, feel free to draw the function, shape the area. You might look back and just go, what? Probably. There's the curve. There's the equation. So it's meant to represent the area under the curve. Between, oh dear, x is something and x is something. It's a little afterthought. Oh, sorry. So you can probably guess what the missing word is. Yeah. Following this investigation, we have discovered that the definite integral is a way of calculating the area under a curve. In the formula booklet, what do they give you for finding the area under a curve between x equals a and x equals b? So it'll be, I've noticed I pasted on the front of your booklet as well, page 1 of your booklet.
A equals twig, B, A, Y,
Oh, no. So twig, so which one's here, A or B? B's on the top?
A is at the bottom,
Yeah.
and then Y, and then the X.
Yeah, so they give you that to remind you that that's your
You guys have this in the last year?
Yeah.
Okay.
Yeah, what page? It's like when I put the list of topics. Yeah, the page after that. I think it's in there. Yeah, like, you know, when I give you the list of topics and stuff, and the chapter exercises, that's when I do that. So, so they give you that thing just to remind you that the area under the curve. And notice the one that the B has to be the bound to the right, and A is the bound to the left. Oh, I mentioned this. Down here, I was about to write that on the side, but I asked you about it. Okay, so what do you think A represents?
Area.
Both? Oh, yeah, A, big A is the area. Is it?
A is the left.
Yeah, the left, yeah. So A is they call it the lower limit. The lower limit for X. You could also call it the X value to the left. So you can decode it into whatever makes sense to you. Officially, they call it the lower limit. So officially, they call it the lower limit for X. I think sometimes they call it the lower limit for integrating, or the lower limit for the integral. Actually, it's probably better. The lower limit for the integral is officially what you would call it. A is the lower limit for the integral. So here just put whatever makes sense to you, like in your own words, to help you remember. Yeah, sorry, yeah, the lower limit for the integral. It is the lower x limit, but specifically for the integral. What do you think B represents? That's something that sometimes people do get a little bit mixed up on. So if anything, like just try to remember that the way it's kind of set up, that's your function, and this is roughly your area. That it goes A first and then B. So sometimes people can get those a little bit mixed. What do you think? What do you think y represents? The function, yeah. Function e.g. x squared plus 1. I think that was the one we were looking at before. And you probably remember this, but what does dx mean again? Yeah, with respect to x, yep. So don't be confused by that thing. It just means with respect to x. Sure thing. See that here? So with respect to x. We could. The sounds. So Bella, the sound isn't working. Bella. So the sound isn't working on the board at the moment. So you're very lucky. I did play you. It's on the TOK intro to calculus last year. I played you this rap. But so I wrote out the lyrics anyway, because it sort of leads on a little bit to integration, like a thing that we're kind of going to finally learn about the history of the twig. Where does the twig come from? Who wants to rap the first verse out loud? Owen, yep. So Owen, can you please be Leibniz? And who wants to be? Yeah, and you're rapping it. And who wants to be Newton? Isaac Newton. Lauren, you want to be Isaac Newton? So it's a call and response. So first of all, there is a video, yeah.
Why is the sound not working?
Because the sound's not working. Okay, guys. We'll just do it fast. We'll do it fast. Okay. All right, Owen. Here we go. So it's Leibniz, then it's Newton, then it's Leibniz and Newton again. Yes, sure.
Wait, so Owen's doing both?
No, Lauren's doing Newton. Isaac Newton. Okay. Otherwise, I'll do it, and that'll be
worse.
That'll be worse.
Owen is going to do it. Sorry. I'm good. I didn't volunteer. Go, Owen. Look at that. I was supposed to say that because I had a guy accent big, but I spit so fly. Calc still stroke, integrate and derive, look at some parts. Oh my, oh yeah, my hair's so fluffy. That's it, it's back line. Do I stop now?
No, you do the whole paragraph, yeah.
All the German girls, they love me. My notation is still used widely. Angle and no jumped on fine. I was the one who made it to S. Integrate both the limits with respect to X. I derive with a G, not dots over Y. And I don't base my theorems on apples from the sky. Scott's product rule, named after my hard work. Leibniz stomps your face in the dirt. So you say you love God and F equals MA. What? I'll accelerate my fist, so you better start to pray.
I've got a feeling that there's not a swear word in here. I'm just thinking of ass. Hello, simpleton. Apply. Dude, I'm really bad. Hello, simpleton. Applaud your attempt at calculus. Remind me who you are again. I am Sir Isaac Newton. It's true you published before me. Calc is the subject of priority. Independent my ass. Shoot the whole crew down. Face full of hot brass. Born on Christmas like a saint. but your holy savior, I sure as hell ain't. I'll approximate the root of all your problems, then use my own power series to solve them. My name will be known till infinity. Your fame is fleeting with respect to tea. I am the people's genius. They're rooting for Newton, not Leibniz. My limit of tolerance for you is 0. Hate what I'm saying, but you know it's true. I scoff. I look with scorn because I wrote a book more popular than you.
Still, your book sold better than mine, and your name might have survived in the sea of time. But if it wasn't for me, that you feel succeed, that your legacy be outlived by a tree. If you sum up the things that you've done with your life, it converges to 0, because you're sad and you're sad and lonely English. Foolish enough to die by her own hand. Yes, if you were an eccentric person, but that's because of mercury poisoning. If you wanted some credit for calculus, you should have manned up to some publishing. Spent half your life looking for the philosopher's stone. The art of alchemy is just a joke as a whole, but of course, impeccable and impossible. And it's simple like you would know. Shut off your simple-minded art would make it so simple.
You're the only negative I'll forget. I'll cancel you from the equation. What about your death? How about one guy at your funeral to answer that question? Not even your friends or family, only your personal secretary. For 50 years, it was never marked that you were buried. Such a boring man. What a tragedy. You're the area under my curve, integrating all of my work. You're like the derivative of A, because plain and simple, just a jerk. With a fake hairdo and a cloak so cheap, like the rest of the Germans, follow the leader like sheep.
Oh, this is rude.
It's so mean.
I think
Oh, so I didn't know Isaac Newton got into alchemy. That's interesting. Alchemy is like trying to use chemistry to make things like gold and stuff like that. Like they tried to, it was kind of, they thought it was a bit like, it was almost like scientific witchcraft kind of thing. So it's kind of like the early forms of chemistry. Yeah. It's just for Talisa and Calvina. So this is interesting. So that led into this. Finally, what does the funny twig symbol mean again? Integrate. Yeah. Integrate. So technically, that integration symbol was introduced by one of the founders of calculus, Leibniz, the German one. It's actually an elongated S, meaning, what do you think it could mean? A 3-letter word starting with S? Yeah, sum.
interesting.
Oh, yeah. Meaning sum. It's actually an elongated S meaning sum. Why does it mean the sum? Yeah.
I put on dry, but it's
So just having a guess, why does it mean the sum? It relates a little bit to what we were doing with that investigation when we were adding. What were we adding together?
the values of it.
Yeah,
The area of each.
lots of different rectangles. Yeah. So, what does it mean the sum? In the investigation on the previous page, we used only how many rectangles? 4. Yeah. So we used only 4 rectangles to approximate the area under the curve. We calculated the area. We calculated the area of each rectangle and added them, yeah. So that's the key thing, we added them. And we added them. So we found the area under each rectangle and added them all together to approximate the total area. Shh, guys, we're doing math. Come on. Lauren.
I've got to do the crisis. Well, did you forget to do your IA? I didn't know it was due today. I missed the day that it was set.
Send an email.
Wait, I thought they said I was on day 4. We don't have it on day 6. Oh, it's beautiful.
I'm
What did I think it's so You did math? I just thought math, a lot of English.
Okay. So send an email send an email and make sure to sound apologetic.
Okay.
Okay, so we calculated the area of each curve and added them together to approximate the total area under the curve. Hence we found that sum, yep, of the areas of the rectangles. Yeah, it's really once more.
I like
There you go. So guys, this is important. Like, it's important theory behind integration. So to get a better approximation, we could do something to the number of rectangles. Close? We could increase. Yeah, increase. Yeah.
You said ice cream. You said yeah.
Oh, they said ice cream. I mean increase. So to get a better approximation, instead of using 4 rectangles, we could increase the number of rectangles drawn under the curve. So it'd be the same width overall, but we draw more thin rectangles in there. More and more until the number of rectangles under the curve approaches infinity. Yeah. So if we make the rectangles closer and closer together, so they become infinitely closer together, then we get closer and closer to, the more rectangles you have, the closer you are to the actual area under the curve. So the thinner you draw the rectangles until they're like basically approaching infinity. The width is, the number of rectangles underneath the curve is approaching infinity. So we can denote this as, do you remember these things?
Yeah.
What's that thing called? The limit? So we call this thing the limit as n approaches, just remembering what notation means, approaches infinity. So the limit as n, the number of rectangles, approaches infinity. Approaches infinity. What does that big E thing mean? The sum, yeah. The sum of. And how do you find the area of a rectangle again? Yeah, base times height. Which one of these 2 things? So there's 2 things here. Which one of those 2 do you think is the height? Which one would be the height?
The triangle.
Good guess. What does the triangle mean inside? Change, yeah. So the change in x could be the base, yeah, because it's a difference in the x values. So the change in x could be the base of the rectangle, or the width. And why does f of x represent the height? Yeah. Yeah, f of x is y, and y tends to be the height of each point, doesn't it? Yeah, because remember we subbed in the x into the function to calculate the height of the rectangle, didn't we? So it's the height. So f of x is like the height of each rectangle. Because if you sub in the x, you get the height, the y value. You could say calculated. So calculated by, if you want to make a note, you could say calculated by subbing x into the function. That might ring a bell then. So it was the height, yeah, so f of x is the height of each rectangle, calculated by subbing the x into each function. So the limit as the number of rectangles approaches infinity is the sum of the areas of each of those rectangles. So that's how it's kind of denoted in this notation. Put in a slightly more simple way, this whole thing here, I'll circle it in yellow, this whole thing here. So rather than write the sum of, Leibniz said, let's just make this, rather than write all that busy stuff, he said, let's just make a shorthand for it. Yeah, and so he invented this symbol, because it's easier, writing that little thing is way easier than writing all that every time. So there's this nice little symbol here.
So how come you didn't make that blue too?
I tried to, but it just wouldn't go blue. Yeah, so I tried to make this one blue, but it just didn't. And I gave up. Yeah, so maybe I should make a blue one here for you. Let's make it blue to point out that it's all the same thing. There you go. Then we sort of made it blue. So that thing became that thing. And so, yeah, because this features the sum, that's why this is the twig is actually an elongated s, but saying twig is easier. And that's the height, or f of x with respect to x. The dx is like the change in x, so with respect to x, sort of. And f of x is the function, of course. And Sarah, how do we say it in the formula booklet again? You mentioned it before. We say it in a simpler way. Yeah, that thing is area equals. Yes, that's it. That's it. So what's the only difference, Bella, between the way it's kind of done here and the way it's given to us in the formula booklet?
There's under it says in the formula book that you don't have something in front of the equal sign, it's just kind of equals.
Yeah, and one other thing?
And then in A and stuff. No.
I know, just left it in the way of drawing it. Yeah, you've got y instead of f of x, yeah. So this is how it appears in the formula booklet. And that's the area.
This is how it appears.
Yeah, this is how it appears. How it.
Okay. Could you read it out this morning?
Seeing it's probably not going to help you much either. I'll just read it out like dictation. This is how it appears in the formula booklet. Now we're going to start to apply all this stuff.
You have a Corey bed.
I know I'm just going to apply it. Don't just wait here. Just if people are writing still. Oh, I'm sleepy. Anyone writing still? Don't think there is. There used to be all sorts of great stuff in here. I got swiped. Someone swiped all our stuff. I need to bring some more over. Okay, so we can denote this visually too. So I left a bit of space around here so we can kind of write.
What does the joke mean at the end of this page?
Does it mean you have 0 friends?
Yeah, why would it mean you have 0 friends? Good point.
Oh, because there's 2 A's.
Yeah.
Because what?
There's 2 A's.
Because the area under the curve,
There is
between A and A, there's no area.
Oh.
Yeah.
You can't do 20.
You have no friends.
No,
you don't need to write it. Yeah. So there is no, and there is no area.
Or right, there's no area between
Yeah. So that's the meaning of that joke. Hee hee hee. And unfortunately, again, I wrote heaps of stuff on my notes for this page, but I'm trying to remember what I wrote. All I did was I just am pointing to each thing on here and saying what it is. So all I've done is, on this one, I've pointed to each one and said what I... You have no friends, as there is no area under the curve between x equals a and x equals a.
Losing class fun on Friday. Oh my god, that'd be fun. That was so fun. No, but then I had to.
So just be aware, this is recording. Okay, so I'm trying to remember what I was writing down. So, this is just a little recap. It demonstrates visually. What does that mean? Yeah, that's it.
Lower limit.
Yeah, the lower limit of, or some people say of integration as well. Or the lower limit of the integral, sorry.
You did about 5 times a day.
No, it was. It's just places.
Like how cool.
I'll just say the lower limit. Okay. Yeah, the limit. What's the blue bit?
The car.
The curve, yeah. The curve. Even if it's a line, they still call it a curve.
My folder was taught by the drums by culture.
This is why it's really good feeling. Because it's just be quiet.
When I'm talking. I'm sorry.
Yeah, right. Okay,
Curve
so
the function,
yeah, the curve, the function, that kind of thing, like the curve.
slash the function.
Yeah.
In brackets the function.
Well, I want to.
I know I probably
I
do.
like slash.
I think I wrote the area.
Yeah, but the slash would make more sense.
It makes more sense than the curve the function.
And in a way, this one part's already labelled anyway. So the area, they've already plotted
Can you
out.
put a
What do you like?
a top of the arrow
Slash would make
for the curve?
But that means either or.
Yes.
Yeah, exactly. It's
means
either
it's
the curve or
It's bigger than the actual arrow.
I got one. You do? Yeah, did.
Okay. All right, you got that?
See.
See, now we're on to actually applying it. Get your calculators out. Woo!
That was the way from a page.
It was a bit. I think when I did my notes, I wrote a lot more, but I think you've got it by now. I just wrote extra stuff that we'd already said. So it says, write down the definite integral, which gives you the area of the shaded region, and evaluate it using your GDC. So basically, I just want you to turn this into this form, and then plug it in the GDC and calculate it, the graphing calculator. So what's our, so we want you to write the integral, so we're going to write the elongated S, or the twig. So practice writing out elongated S. So do you remember at the top, do we write the lower limit or the upper limit?
Upper.
Upper, yes, I think lower, upper, if that helps, lower, upper. That only just occurred to me for the first time, lower, upper. Not really.
No,
Okay,
yeah,
so-
baby.
What's our lower limit? Yeah, -2. What's our upper limit? Yeah, it's actually -1, yeah. What's our function?
We don't have that on our paper.
Oh, yeah, I forgot to stick it on yours. Sorry about that. Yeah, so it's meant to be on there, so don't worry, you're not expected to look at it and know what the function is. So I just forgot to stick it on your one. So,
Did it say 2 to the what? What's that to be 2? Is it 7?
What is the function, Miss Maloney?
yeah, it's meant to be that. That was meant to be on your page.
What's
Sorry.
that little?
So what's this one?
Oh, it's just I took a snip badly. So I snipped it from the text in the book I stole it from. So it's not meant to be there. So let's get rid of it. Okay, that's better. And then what have I forgot to write at the end? Yes, yep. Yes, yeah. And then you bung it in the calculator and off you
You
go.
want it?
Yep, bung it in the calculator. And so you're fine calculating the area.
What?
2.
I got -2.
-2?
No, I did it wrong.
Yeah, so so Bella, get that calculator going then.
She took my pencil case.
Guys,
I just need
calculators.
Yes, that's what
I got 2.
So you got 2? Okay. Girls, come on. So if you're forced to give units, what would you say?
Units.
Units squared.
Square.
Yeah.
Wait, why does it equal 2?
Put in the calculator. Just remember.
Sorry. Where's the calculator, Grace? Right here, Lauren.
So you would go math 9. You'd put in -2, -1. And see what you do, you put in 4 over x squared. How do you make fractions again?
Alpha y equals.
Y equals good, yeah. Alpha y equals n/d.
Yeah. And then you got what?
And it's still the wrong one. Yeah, it'll work. And I finally just gave you it.
Yay! Okay, nice. So and then we do the next one. Okay, so we're practicing with calculator. You can also do these non-calc. So basically you sub in the upper bound, sub in the upper bound into here, and sub in the lower bound, and then subtract it. So the upper bound subbed into here, the lower bound subbed into here, and then subtract. Do you want me to show you that by hand?
Wait, what did you say, Miss Willie?
Yeah, if you have to do it by hand.
Oh.
By hand.
Oh.
Sub in the upper bound first, and then subtract the lower bound subbed in. So it would be 4 over -1 squared minus 4 over -2 squared. Yeah, that's what I feel. The minus is always there. So the minus is something you always do. You always sub in the upper bound, and then sub in the lower bound, and do the upper bound subbed in minus the lower bound subbed in. Yeah, so what's -1 squared? 1. 1, so 4, yeah. Minus.
That's just 4, isn't it 3?
4 minus 1.
It's 3. That doesn't make sense.
Have I done something wrong?
No, it's just 4 more. Yeah, it's just. Oh.
Yeah,
I
exactly,
get what
yeah.
you mean about. ¿Qué pasó?
Let me get 3. So I must have done something wrong. Sorry about that. Am I doing something wrong? I don't know. I'm lost. But this was definitely 2, wasn't it? Okay, so we're assuming the calculator one's right. And by the way, the calculator one. Oh, sorry about that.
Can you erase me one? Just move on.
What was I doing wrong? I'll realize afterwards what I did wrong. But at the moment I'm just not. So sorry about that. Leave it for now, Lauren, and then next lesson we can finish.
-2 first, and then it's 1 plus 4, which equals 3.
Oh. Hang on, maybe, yeah, I keep forgetting. Or is it, do I have something in the lower bound first? I'll show you an example of one that was done by hand. I'll show you an example of one that was done by hand. For example, x squared. Yeah, so, hang on.
What?
I'm just showing you an example of one that was done by hand. So this
I
one,
don't understand it.
yeah, that's what I'm just pointing out. Let me explain it.
Where did the x cubed come from? Oh, this is our economics class.
There's no x cubed. So I'll make it bigger so you can see it. Yeah, you probably just couldn't see it. There you go. So here's one that was done by hand. Find the area between here. If you didn't put it in the calculator, you could do it like this. See, you can rewrite it. This is a way when we will be doing stuff by hand. A quick thing that quite often people do is they take this and they just rewrite it like this, and then they've subbed in. Yeah, they've subbed in 3 first, haven't they? Yep, subbed in the upper bound minus the lower bound. Lower bound subbed in. Yeah, because upper bound subbed in would give 27 over 3, which is 9. Lower bound subbed in would give 1 over 3, and then subtract them. So what did I must have done something small wrong.
Where did they get that x equals 3 over 3 thing?
Oh, they integrated. Oh, that's what I didn't do. I see what I didn't do. I forgot to integrate it. Yeah, sorry about that. That was, yeah, so that makes sense. That's good that we realized what I did wrong. I forgot to integrate it. I forgot to integrate the functions. So on my little bad one, I'll show you what I did. I just subbed it into the function. I forgot to integrate the function first, sorry. So do you want to do it by hand?
Yeah.
Okay, yeah. So we'll integrate the function. We've got a little bit of space, so just write reasonably small. So by hand.
It's crazy. This is how they made me.
So by hand, you would kind of just rewrite it. 4, so just try to think 4 over x squared is the same as 4x to the power of 2. -2, yeah? Oh, I'll do that in green just so you see it is the original function. So I'm finding it hard to write down here because there's not much space on
Oh,
the
we're not
screen out there.
integrating.
Yeah, so how would you integrate that? So you raise the power by 1.
Yeah, so 4x was
4x to the negative 1 divided by
1.
What?
No.
divided by
Negative 1, yeah. You always divide by the new power. So 4x to the negative 1, and then you always divide by the new power. Negative 2 plus 1, yeah, negative 2 plus 1. What does that simplify to? Like dividing by negative 1?
negative 4 divided by negative
Negative
1.
4x.
Yeah, negative 4x to the minus 1, which we could rewrite as negative 4
Over x.
over x. Yeah, oh gosh. Look at that. Look at that.
Look at that.
Really neat. Negative 4 over x. And then between negative 1 and 2, and negative 2, sorry. And at this point is just where the board decided to stop working.
Always wrote that one time.
Isn't that weird? And what makes that happen? Can I do it on this? No, I can't do it on that even. Okay, so negative 2, it's 940. We could just stop there if you wanted.
We can't finish it.
Yeah, you can definitely finish it, yeah, but I just can't write on here anymore. I'll just have to quickly close and reopen it, which does work as well. So I'll close and reopen, and it takes a little while to get there. So this is the problem when I leave my notes over there. I miss a little point like that. Here we go. There you go. That's because I was writing on it. So isn't it funny, even though it doesn't show the writing, everything I was trying to write, it comes up afterwards. Okay, so not purple. So negative 2. And then if you sub in, now if you sub in the upper bound and then subtract, the lower bound subs in. So Bella.
Yes.
Negative.
Negative.
Yeah. Over.
Oh, I'm giving the answer.
Negative 1, yeah. And then you always minus, so that's why I'm doing a different colour, just to point out you always minus the lower bound subbed in. What would I write next, Bella?
Negative 2.
Sorry?
Negative 4.
Negative 4 over negative 2.
Yeah.
Then we just work out what that is.
Interesting.
What's negative 4 divided by negative 1?
4.
You give us the right answer this time. Minus.
Yeah, it is the right answer.
Very good, yeah.
Yay.
Right. So you don't need to for each of these be doing it by hand, but you can if you want. This one's a really hard one. Like this would be a lot of messing around to integrate. So you might just
You
use
could do
one
that
calculator.
one now.
But also notice, you could also do it geometrically. So what kind of shape is it? Yeah,
Yeah,
it's a
quarter of a
quarter of a
circle.
circle, yeah. And what's the formula for this? And what's its radius?
2.
2. And how would you work out the area of it?
Pi r squared.
Yeah.
You could use a 5
Yeah.
Divided by 4.
By 4, yeah. Pi r squared divided by 4. Yeah.
Yeah, makes sense.
So that's another way you can verify that you've got the same area. So we'll continue this next lesson.
Oh, you're
You guys think that my missing chicken will be good?